So in this last set of videos, we're going to go through the Drawing Workspace, the last one we haven't looked at. For the Drawing Workspace, we're actually going to base all of our drawings of our leg subassembly that we modelled earlier. So go into your data panel, open that up. I've got it open as a separate tab already. Once you're inside, we're going to go into the workspace options and choose Drawing from Design. Now be aware that there is the From Animation option. We discussed this briefly in the animation video earlier, where you can use an exploded view to create an engineering drawing. We're not going to do that in this case, but you can do that if you want to. Click on From Design, and it's going to ask us what we want to put in our engineering drawing. We can choose Full Assembly, Visible Parts Only, or select what we want. Here you have some other options that you can change. You can base drawings off a template that you might have. So if you generate a template with a specific title block or size, you can use that. You also have your standard, your units, and your page size. I'm going to leave mine as A3 just to give me a little bit more space. Click OK, and Fusion will take us into an engineering drawing file. Now Fusion stores all engineering drawings as a separate file that is then saved into your data panel and your project. That doesn't mean though that it's not linked to the original file. So if I go in and change something with our leg subassembly, I can come back into the drawing, update it, and it will automatically update. It is absolutely linked. Now that we've opened, Fusion 360 has automatically given us our base view. I'm just going to cancel this so I can show you where it is. But as with Fusion, you go from left to right, and our base view is in our top left. It is our main start to an engineering drawing. If it hasn't automatically done, click on the base view, and we're going to place our base view into our drawing. We have a dialog box on the right hand side that we can update. We can reference it to a previous drawing, represent it as a model, and we can change its appearance. We can either look at the front, or actually I'm going to look at it from the right hand side because it gives a slightly more clear view for our base view. I can also change it to visible and hidden edges, or how it's shaded. Now be aware that currently it is still shaded because I haven't clicked OK. But once I do click OK, what happens here, what you've chosen here, will be implemented. So you'll see in a second that I only have visible edges selected, and it won't show us any of the colours or the shape. You can also change your scale here. I might make 1 to 2, I think is a pretty good size, but you want to base your scale on the size of the part compared to the size of your drawing, so you can fit everything in with lots of spare room. Otherwise it's going to be very unclear in your drawing. Once you're happy, click OK, and you'll see that this is now changed to a wireframe view. You can click on the square in the middle to move it around. I'm going to put it near the top left, I think. After this, we can go in and create a projected view from our base view. You can find this as the second option, projected view, and you base it off the first. Sometimes you have to click on it, and all you have to do is drag to the direction that you want. Now I'm going to have one from the top, just dragging it down, one from the side, or in this case the front, and one isometric 3D view. Once you're happy, you can click on the tick, and these will all change. If you want to, you can always double click on an item and change it to a different view. So sometimes, if you want to give a good representation of your part, you can change just your isometric view to be shaded. In this case, I'm going to base it off the parent, which means that it's based off the base view that it came from. Past that, we can also do different types of views. Within our drawing views, we have a section view and we have a detail view. If I select a section view, it allows me to choose a part and then draw a section through it. So we can show in our drawing a section. You'll click on one side of your section, you'll click on the other side of your section, and then it'll ask you for a direction once you click on the tick. If you put your section above, then this is what changes the arrows. I'm going to put mine just below, and you can click confirm, and again you can change your views and everything. You can also change what is cut, so if you only want one component to be cut out of the drawing, you can do this as well. Click OK, and I've got this hashed view to show that it's a cut through part. You can see that because we're cut through the middle of our curve on our main part, this one here. You can also do a detail view. So we could go in, choose the detail view, and we could click on our part, select the center of a circle, and then create a detail view of that. I'm just going to put that up in the corner there. You can move these parts around as well as their text, and I'm just going to bring this one in a little bit here. This is just giving a bit of detail on what it is, and it zooms in that circular fashion. So if you have a really small piece of detail, this can be a really useful tool. That's our main drawing views. After that, we can modify. We can use the move tool to move things, as well as just dragging their boxes, or you can rotate them. Past that, we have other geometry that we can add. We can add a center line to different parts. For example, I could select a center line between these two parts here, or a center line between our feet. I could also add a center mark. So for our holes, for example, I could select a hole to give a center mark. There are lots of different other geometries. You can change center mark patterns or edge extensions. But after that, we get into our main part, which is our dimensions. This is ultimately what we're here in the drawing view to show. It's the dimensions of the part and how we can make it. You can press D to create a main dimension, and all that it takes is using these green squares that pop up to select 2 points to create a dimension. Very similar to how you do it in a sketch. For example, I could select the line on the right hand side here and the line on the far side, and it would give me this dimension. In this case, 115.1 millimeters for some reason. I could also choose points on the end. Now notice we have these fillets. There's also 12.1. Our overall width is 62. And you can go in and add all of these dimensions, making sure that you add all the parts that you need. There are also other types of dimensions. You have a radius dimension or a diameter dimension. Now you can use the normal dimension tool for these, and Fusion will try and automatically select what you should use, but sometimes it doesn't quite get it right, so you can choose the specific type of dimension that you want. So for example, I could come in and choose the diameter that I want here, and it uses the diameter icon. I could also go in and choose the radius for our fillets, for example. So I know I have a fillet on the end here, and I can select what radius that fillet is. There are a number of other dimensions that you can choose and other ways that you can create dimensions quickly. But you should note also that you can double click on a dimension and you can edit it slightly. Anything between the brackets is what is automatically generated. You can change the precision, the number of decimal places that it is to. You can use alternate units for that specific dimension. You can insert a symbol. So for example, I could insert a plus minus, and if I zoom in here, I can actually type within this 0.1, for example. You can also add its own specific tolerance in the way, depending on how you want to do your drawing. The next section across is text. Now you can add just a standard piece of text as a box and type in whatever you'd like. You can also add a note to a part. So for example, I could say that this is radius of whatever if you want to explain something in your drawing. And you can delete lines as well just by selecting them and pressing delete. Other things such as the hole and thread note are really useful. In this case, we don't have any threads or main actual holes that we've used, we just extruded circles through. This is another reason why using the hole tool is really useful. If you use the hole tool using the hole and thread note, if you select that hole, it will automatically generate a note with the exact sizings that you need. Especially with a thread, this is really useful because it saves you having to type it all out technically. It just tells you exactly what the hole size is, what the thread, what the pitch, and what the specifications are, just by selecting that thread in your drawing. There are some other symbols as well for surface texture, datum identifier, and you can add in labels for tapers and slopes, as well as for welds. Finally, for a sub-assembly or an assembly like this, you might want to add in a table. I'm actually going to move this part up slightly, my isometric. I'm going to insert a parts list. I can select where I want to put this. I can choose corners. I can put it down on the bottom here, for example. Gives me a bit more space. And it will come up and it will give us our parts list. Now this is automatically generated from the component names that we've put into our file, as well as the materials that we chose. And you'll notice that it's also automatically added these bomb balloons, which identify which part is which. You can move these around if they're slightly hidden, but it allows us to label the item so that the person reading it knows which item is referenced in the table. You can add these balloons on your own manually if you want to, and you can also do stuff like aligning balloons to certain parts, and you can also renumber your balloons. So if you want them to be in a specific order, you can renumber, and then you can select the order that you want them. So 1, 2, 3, 4, for example. It's a really easy way just to adapt how you want to show the parts. Once you're happy with how it looks and you've added all your dimensions, what you want to do is you want to output your file. Now you can either output it as a PDF, you can save it as a CSV, a DWG, or you can output the sheet as a DXF as well. Alternatively, don't forget that you can always save it, and we probably should have done this before, as the leg subassembly drawing in your hexapod folder. But it is quite useful to be able to export it straight as a PDF if you want to. The next part we're going to design or draw is one specific component of the subassembly. Now what we can do is we can go in and we can create a new sheet at the bottom. As we create all of our components, you add up all the sheets at the bottom. Now you'll have noticed I just brushed over this, but you have down at the bottom the title block. You can double click to edit your title block and add in parts. There's a specific properties that you have in here already. Now you can create templates or you can design your own title block if you really want to. You can right click on the title block and say edit title block or new title block. And this would allow you to create a new one, edit what's there, or import one. In my case, I'm happy with this layout, so I'm going to go in. The department is for videos. I don't know. You can add in all the information that you want here. You can add in the references and everything. Once you're done, you finish, and you see that this is written in. You'll also notice that we have the sheet 1 of 1. And if I create a new sheet down at the bottom, you'll see this is now 2 of 2, and the original one is now 1 of 2. So you can create all of these sheets and it will automatically update for you. In our second sheet, we're going to focus on just one component. So I'm going to create my base view, put it in the middle, and the component that I want to do is going to be this. What do we do? Let's say we do the servo block. So in that case, I'm going to go to the right again so I can see everything. Because the servo block's not the entire size, I'm actually going to make it 1 to 1 so I have some space. And you'll notice that on the left hand side here in our browser, we can select more and we can deselect parts that we don't want. Now I want the servo block, so I can right click on this and suppress all except for the one that's selected, much like we did in the simulation video when we simplified our model. This will leave me with just my servo block left as my base view, and then I can go in, do a projected view of that below, to the side, and in my isometric view. From here you can add your specific geometry. If you want, you can add your center lines, and it allows you to add in your dimensions if you want to reference these two holes, the distance between them. Now notice that again, with dimensions and sketches, you can do the 3 different options of dimensions, and you can also move these around. So once you have your dimension, I can move the whole dimension. I can move the different arrows in different ways, depending on the different dimension that it is. If I want it out to the side, I can do that. So you can really move parts around to make sure that it looks really good, as it is very obviously important that you make it as clear as possible to the person that might be reading it. You can go in and change your title block again, add in your parts, but I just wanted to show you how you create your second part. And you just keep adding sheets, selecting the components that you want to draw, and at the end, when you output, you can output PDF, and you can choose to output all of your sheets as a single PDF, which allows you to just save it as one file to send out. It also means that when you save it, you can update what you can say what you've changed in your version history, because drawings also have version history, and you can have all of your drawings down at the bottom. That sums up just a really brief way of how you can do some engineering drawings. Obviously there are a lot of tools here, and you need some common knowledge on how to do specific engineering drawings technically correctly. But I've hopefully shown you the tools that you can use to do that in Fusion 360.